All right, let's dive right into this explainer and take a cosmic road trip outward from our local star all the way to the icy fringes of our neighborhood. We're going to explore the incredible scale, the intense temperatures, and some of the genuinely surprising quirks of the solar system we call home. Here's our flight plan for today. We'll kick things off with the Sun, tour the inner rocky planets, fly past the outer gas giants, and finish up with asteroids, meteors, and comets. This layout straight from NASA really puts our neighborhood into perspective. And if you ever need a quick way to remember the order of the 8 major planets, that classic mnemonic still works perfectly. My very energetic mother just showed us night sky. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Pretty handy, right? Okay, section 1. Our star, the Sun. Sitting about 150 million kilometers away from us, our anchor star is a place of absolute extremes. And the temperature profile is honestly kind of wild. You logically think it just gets cooler the further out from the center you go, right? Well, it starts at a blistering 15 million degrees Celsius in the core. And it does drop to about 6,000 degrees at the visible surface, the photosphere. But then, completely defying expectations, as you move further out into the atmosphere, the corona, the temperature actually spikes back up to a staggering 2 million degrees. Now, unlike Earth, the Sun isn't made of rock or metal. It's essentially a massive 4.6 billion-year-old ball of burning gas. We're talking roughly 73% hydrogen and 25% helium, with just a tiny 2% sliver left for trace elements like oxygen, carbon, and iron. It's going to keep shining for about another 5 billion years before swelling into a red giant and ultimately ending its life as a compact white dwarf. Moving on to section 2, the inner rocky planets. So before we zoom in on the individual planets, it's absolutely crucial to understand this core divide. Our solar system is neatly split into 2 main camps. On the inside track, we have the terrestrial planets, small, dense, rocky, with tight, fast orbits. Out beyond them, we have the outer planets, massive, gaseous giants that take practically forever to complete just one trip around the Sun. Flying past those first 2 inner worlds, we see some serious extremes. Mercury whips around the Sun incredibly fast. It's got the shortest orbit of the bunch, and 0 moons. Then there's Venus. People used to call it Earth's twin because of its size, but frankly, it is an absolute nightmare world. It's the hottest planet we've got, permanently smothered in dense clouds of toxic sulfuric acid. Oh, and get this, Venus actually rotates on its axis clockwise, which means it's spinning completely backwards compared to almost everything else. Next up is home, Earth. It's the only place we know of that supports life and uniquely features water in all 3 states, liquid, solid, and gas. A bit further out, we hit the cold, red deserts of Mars, getting its iconic rusty look from iron-rich soil. And despite being on the smaller side, Mars does not mess around. It's home to Mons Olympus, the single largest volcano and second tallest mountain in the entire solar system. All right. Section 3, the outer gas giants. Crossing over into the outer solar system, Jupiter is the undisputed king. It is literally 2.5 times more massive than all the other planets combined. Just an absolute monster. It also features the Great Red Spot, a raging storm 3 times wider than Earth that's been churning since at least 1831. Next is Saturn, bringing the visual drama with its massive ring system of ice and rock. But here's the crazy part. Despite its colossal size, Saturn is so undeniably airy that if you could somehow find a bathtub big enough, the entire planet would actually float. Pushing further into the dark, we find Uranus and Neptune. Uranus has this beautiful cyan color, but it's completely knocked over. It spins tilted entirely on its side, so its poles are right where the equator should be. Finally, we reach Neptune, the outermost planet, rocking a deep blue color from the methane in its atmosphere. The coolest thing about Neptune, its existence was actually mathematically predicted based on weird gravitational tugs on Uranus well before anyone ever spotted it through a telescope. Math literally found a planet. And the gravitational pull of these gas giants is just staggering. Look at these moon counts. These planets are practically mini solar systems all on their own. Jupiter has 67 known moons, including Ganymede, which is literally bigger than the planet Mercury. Saturn has 62, including Titan, a moon with a thick atmosphere and, no joke, ice volcanoes. Uranus hosts 27, and Neptune has 14, including its massive moon Triton. Now, before we officially leave the planets behind, we have to talk about an old favorite, Pluto. Once our 9th planet, it famously got demoted to dwarf planet status. It's sitting way out there in the deep, icy cold, but it isn't lonely. It actually has 5 moons of its own orbiting around it, including Charon. Wrapping up with Section 4, Asteroids, Meteors, and Comets. Asteroids are essentially like planets, just way smaller and usually non-spherical. Basically, they're giant, jagged space rocks. While there are millions of them orbiting the Sun, most are clustered together in a massive belt that forms a literal rocky boundary between the inner terrestrial planets and the outer gas giants, sitting right between Mars and Jupiter. The absolute biggest one in there is called Ceres. Okay, people mix these space terms up all the time, so let's lock this down for good. When a rock fragment is just floating around out in deep space, it's a meteoroid. When that same rock hits Earth's atmosphere and friction makes it burn up in a bright streak across the sky, what we usually call a shooting star, that's a meteor. And if a chunk of that rock manages to survive the intense heat and actually smacks into your backyard, that is a meteorite. Unlike those rocky asteroids, comets are the icy wanderers of our solar system. They have these highly elliptical orbits that sling them from the deep freeze of the outer edges right up close to the Sun. And when they get close, all that ice and gas heats up. This rapid heating creates a massive, glowing tail that always points directly away from the Sun, driven by the solar wind. They really put on an absolutely spectacular show. The absolute most famous of these icy wanderers is Halley's Comet, which swings past Earth every 75 to 76 years. The last time it graced our skies was back in 1986. It is out there right now, silently looping back towards us. So I'll leave you with this to ponder. When it makes its grand return in 2061, where will you be looking up from? Thanks for joining this explainer, and keep looking up.